All right. Hi, everybody. I'm Emma Brady. I was the instructional designer for this course with Dr. Harpy. Dr. Harpy, as Julia outlined this morning, is a super busy guy and couldn't make his way across campus from being here earlier and coming back, so he left me to speak on his behalf. Anything I get wrong, you can just kind of keep to yourselves, and anything you want to tell him about how good I'm doing, feel free to send him an email. If you have questions about his development process, he'll be happy to talk about it because he had a really actually pretty good time. This course is a course with an embedded lab, and I'll just do a fast overview of the course, and then I'm going to talk specifically to the labs themselves and how they were used, and hopefully will be used in the future for practice in formative and summative assessment. The lectures include, there's 3 labs, and there are 4 lecture sessions that are set up before. We really wanted the students to be able to also see an online, or to be able to see what labs on UF campus look like. So we also brought them into campus labs. And this is a green screen lecture that allows us to see small video and zoom in and out. We went to labs here on campus that showed current research that applies right directly back to their learning objectives. We gave them some hands-on experiments to do at home to talk a little bit to those actually touching of materials, drawing hand-drawn diagrams, labeling things, deciding how you're going to represent that drawing and diagram observation for the other students that you're collaborating with, to kind of give students the sense of how communicating what you observe is also really important in science. And then that brought us to our virtual labs. There were 3, one in embryology, one for discovering the regenerative capabilities of mammals and of, actually not just mammals, of all vertebrates, and then the invertebrate C. elegans gene discovery lab. So Labster is a company that is out of Denmark, which makes collaboration sort of interesting. We've met with them once in person to talk about learning objectives, and then did a lot of our development through Google Drive and collaborative documents that way. All of the content that's here is directly generated by Dr. Harpy. So it started with objectives written by him and actually Dr. Maiden as well. And then the activities that were created were built from those objectives, sometimes with suggestions on certain syndromes or diseases that we could use as a point of interest to build from Labster, and sometimes just on specific sort of experiments and things that students normally should do. I am working with Labster right now, and they were going to give us a screencast of all 3 labs for you to see, because there's licensure issues for showing the labs here in a live audience. And so they were due last week, but they didn't quite get them to me. So I thought I would just show you a couple of their drafts so you can kind of get an idea of what the lab itself looks like. And they haven't done the voiceovers for these yet, so I'll speak to it while it works. The students have these embedded questions that are written by Dr. Harpy, and they are able to perform experiments in which they are able to make mistakes that mess up their experiments and go back. Those mistakes are all preconceived by Dr. Harpy as well. What could happen has all been thought of. And so students also learn what the tools are that they'll be looking at in the actual field. And then they get some imagery of close-ups, and we've also were able to give them also specific diagrams, images that were woven into the whole interface of how they built it over time. As an assessment tool, there were 2 sort of ways to think about it. One is mastery, but it sort of speaks to that student-centered idea, in that the students could answer the question as many times as they wanted to, but they lose 2 points every time they answer as the maximum they can get. They can never get a negative score. There's a minimum of 2 points. And the questions have to do with both what's happening in their laboratory situation, but also what happens is related to the theory and conceptual things that are taught in the lectures. And that theory is here under another place where they can go back and refer if they're still having trouble understanding the answers. One of the things that I think is great about it is if they do mess up and they go back, it scrambles the answers again. And so they have to continually be thinking, not just like, oh, okay, A is not right, B is not right, C is not right. So they do have to be paying attention in that way. Here it also helps for students to understand their progress and what their score is out of, so that they can decide to stop if they want to. Because if they're not prepared for the lab, then maybe they need to go back and look at the lectures again, do some of the readings again, ask some questions of their peers or Dr. Harvey. That's because you can only finish the lab one time. The final finished lab is what's the score that's pushed to the gradebook. And so students can attempt the lab and be in the middle of the lab, mess around in the lab for as many times as they like. But if they finish the lab and call themselves done, then that lab gets pushed to the gradebook. And in Canvas, there's an unpublished dashboard module that allows the instructor to see how many attempts have been made, how long they spent in those attempts, what the percentage score, and how much they completed for each of those attempts. And if a student is an A student and they're doing well, you really don't need to look into that. But if you wanted to get more granular about each student, you can look at each student's behavior. So if you had a student that was doing really well in exams but was struggling in these labs, you might be able to go back and see if it was how they were accessing, how much time they were spending. And so the dashboard has become really, really valuable. We built this whole integrated lab at the same time we were offering the course, which was dangerous at best. The first lab went out and it had to be assessed, but the assessment dashboard and tools weren't there. So we also conceived of these quizzes that would be given after the lab. And one of the challenges we found is that when students got to a simulation, a virtual simulation, it became clear from their feedback and also their performance on that first quiz that they thought of it as like a video game sort of fun aspect of the course and didn't really take it very seriously. Their scores showed that on the first quiz. When we went back and explained, like, the lab is what shows us what you're doing as far as application and synthesis of this knowledge, they began to realize, like, Dr. Harvey made these labs. Oh, this isn't something you bought from a company or a website that you've gone to. And that made a significant difference in how well they paid attention. And we're really looking forward to kind of setting those expectations and explaining grading a little bit more deeply next time, so that students are prepared to understand that the lab is a performance, and that performance is assessed by Dr. Harvey pretty closely. Oops. Oh. Let's see. The other challenge that we had was collaboration, which is something that happens naturally in a lab situation, which is one of the drawbacks of doing a virtual lab. And we've worked with Labster back and forth here a little bit, and they have some innovative ideas for how to make those labs collaborative. Right now, the students just work on their thing in their lab, and if they have questions, they can go to a discussion board. The lab work was interesting because there are some times where you have to do things that you would never ask a student to do in a face-to-face lab multiple times, like you have to remove a salamander's leg. There's costs that go with that as far as growing the specimens. And so this lab enabled us to do things that we would never have been able to do in the virtual lab or in the on-ground lab experience. There were some items that were too costly. There were some items that were too dangerous to do. And so the lab experience for this course online is actually much more robust than it is for the on-ground students. The way that Labster is starting to address collaboration is to make those Labster virtual lab spaces virtual reality. That is also two people could go into the same lab together and perform experiments together. So that's the future. They were saying 2-3 years. And so we're kind of building, also thinking in that vein, that if we're going to have a virtual lab, how can we help them do that development? That's our course. Does anyone have any questions? Go ahead, Phil.
Yeah. So we've looked at labs, and obviously you're trying to build a virtual reality that actually represents the physical laws of real reality.
In some ways.
Well, if it doesn't, then I don't know why we're doing it.
Well, we're doing it because the physical realities like time and space are part of the limitations of being able to collect data and
The
analyze
laws,
it over time.
the laws, not, it doesn't have to be real time, but what you're trying to do is represent the physical laws of our universe, not an alternative.
In physics, sure, but for these
Okay,
laws
all right,
specifically.
let me just, forget I said that.
Okay.
The environment in the lab is a gaming environment, a Second Life environment? Is it more like Myst than it is, you know, remember the old game Myst? Is it like Myst, or is it like Second Life, or is it like Castle Wolfenstein?
It's a single person that has control over all of the lab equipment and is given a problem to fix or a decision to make. Or if you don't know enough information, they'll give you an option to do an experiment to try to figure out more information to answer that question. And so in some ways, it's not really like a quest. It's not really gamified as a Myst sort of quest, but it is single person going through the lab.
And the experience is multi-halved in that the activity is not meant to be linear
Exactly.
or predefined.
Exactly.
Okay, that's the hard part, right?
Right. That's why it
How
costs a
did
big
you
bucks.
visualize that? Is there a flow chart?
Sure, yeah.
Okay, can you show us one of those?
I don't have one of those flowcharts. That's Dr. Hartley's.
Okay, thanks.
So have there been any studies in terms of how well this simulation prepares them for, you know, a real world scenario?
Well, for this one, not yet, but we are putting together a study for next semester to compare the on-ground course with the virtual course. As far as preparing for the real world, that's a multifaceted question because preparing for the real world, analyzing what happens as far as data collection and what happens when you change this variable or that variable, there's a lot of room for practice that there. Real world, like can I cut a salamander's leg off?
Yeah.
Maybe not. We did find some people in here that were like, I really didn't think about the fact that in the future, if I do model organisms, I'm going to have to cut things legs off. This might not be the field for me. And then we had people say, I'm really interested in this field. It's a stepping stone to a medical career or something where I can understand now how this works and how regeneration works, how suturing something changes, how it can regenerate, change all of those variables. Well, I don't think I would have wanted to do this experiment live, but now I understand all the different kind of variables that could happen around this experiment and can take that information with me. So I think that sometimes a lot of the reservations with virtual labs is that they're canned and that they don't address specific objectives for specific disciplines in specific industry and fields. And so what we try to do with this course is take specific objectives that the students need to specifically address and find all of the branching pathways that could be misconceptions and build on those specifically.